Have you ever wondered why some elders seem sharp, joyful, and full of life, even at 90? Could the secret be music? Welcome to Old Wisdom Podcast, where we uncover timeless habits that defy age. In today's episode, we explore how melodies, rhythms, and even humming your favorite tune can actually protect your brain, improve memory, and keep you young at heart. Let's press play on this powerful secret.
Welcome to the deep dive. Today, we're plunging headfirst into something truly amazing, the intersection of, well, science and something deeply human for all of us, music. We're not just talking about catchy tunes, or songs that make you want to dance. We're asking a deeper question. How does music actually keep our brains young? Think about those incredible stories you hear, like an 85-year-old grandmother, maybe forgetting names sometimes, but she sits at the piano and plays Chopin perfectly from memory. Or someone with Alzheimer's struggling to remember family, but then a Beatles song comes on and boom, they sing every single word.
Exactly. And these aren't just touching stories. They're like little windows into some really profound neuroscience. They hint at our brain's hidden capabilities.
So our mission today is to unpack the how and why. We want to explore why musicians' brains might age differently, how even just listening can rewire things up there.
Okay.
And maybe reveal how music could be this powerful anti-aging tool you're not fully using. If you're curious about keeping your mind sharp, building resilience, or just understanding why that playlist matters so much, you are definitely in the right place.
And it's such a fascinating area. Music neuroscience is, well, it's exploding right now. Scientists everywhere are really digging into music's effects on the brain. We're past just saying music does something. Now we're figuring out the mechanisms, the how and why it's so important for, lifelong brain health. This deep dive aims to connect the dots, pull together findings from different labs, and really paint a clear picture of how music supports your brain. And it's knowledge anyone can use, musician or not.
Okay, let's start right at the beginning then.
Yeah.
What actually happens when, say, sound waves from my speakers hit my ears? How does that become music in my head? It sounds simple, but I guess it's not.
Not at all simple. It's quite a journey. So imagine those vibrations traveling through the air, right? They hit your eardrum.
Okay.
That makes the eardrum vibrate. Then, deep inside your inner ear, tiny little hair cells convert those physical vibrations into electrical signals.
Electrical signals.
Yeah. Yeah. And these signals then shoot off along the auditory nerve towards your brainstem. But that's really just the first stop.
The first stop. So it's not like a direct line to hearing.
Nope. From the brainstem, the signals travel up through various other brain structures, eventually reaching the auditory cortex in your temporal lobe. That's where the conscious perception of sound really starts to happen.
All right. So the signals arrive at the auditory cortex. What then? How does the brain turn those raw signals into, say, recognizing a melody or a beat?
This is where the magic happens. The brain performs this incredible act of reconstruction. It takes those, frankly, quite messy electrical signals and reassembles them into what we perceive as structured music. It's identifying pitch, the quality of the sound timbre, rhythm, harmony, all at once.
That sounds computationally intensive.
It really is. Music is inherently, structural. It's mathematical, almost architectural in how notes relate to each other over time. Your brain is doing constant real-time computing, recognizing patterns, predicting what's next, analyzing relationships between notes, chords, everything. There's research like from Johns Hopkins using fMRI scanners. They've watched the brains of jazz musicians and rappers while they improvise.
Oh, yeah. What did they see?
Just vast areas of the brain lighting up like fireworks. It shows intense, widespread activity across many different regions, all working together.
So it's not just the hearing part of the brain working overtime.
Not even close. It engages so much more. That's why we often call it a total brain workout. It involves way more than just the auditory centers. It's a whole cognitive symphony.
A total brain workout. I like that. Okay, so that's processing sound. But what about actually making music?
Yeah.
You hear people say playing an instrument is different. How different is it from just listening?
That's a really crucial distinction. Listening is definitely beneficial. We'll get into that. But active engagement, playing, singing, even just consciously tapping along it dramatically amplifies the brain's response.
Amplifies it how?
It kicks neuroplasticity into high gear. Neuroplasticity is the brain's amazing ability to basically rewire itself, to change its structure and function based on experience.
Like building new roads in the brain.
Exactly. Or widening highways, making connections stronger, more efficient. And active music making seems to be one of the most powerful ways to drive that process. It's like being the architect and the construction crew for your own brain networks.
So architects and construction crews, what kind of specific changes are actually happening? Are we talking physical differences in musicians' brains?
We're talking both functional and structural changes. It's quite profound. First, there's this widespread neural activation that's even more intense than listening. Research by people like Dr. Robert Zator shows that when you make music, information just floods through networks all over the brain.
Like where?
Well, your motor cortex fires up, planning and executing movements. Your limbic system, the emotion center, is highly engaged, linking feelings directly to the sounds. Your prefrontal cortex is busy analyzing patterns, predicting what comes next, solving problems on the fly.
Even the cerebellum. Isn't that just for balance?
Traditionally, yes, but we now know it's crucial for rhythm and timing in music. It acts like a super precise internal clock. It's a truly whole brain activity.
Okay, so lots of activity. But actual structural differences, you mentioned those two.
Yes, absolutely. Take the corpus callosum. That's the big bundle of nerve fibers connecting the left and right hemispheres of your brain.
Right, the bridge between the two sides.
In musicians, that bridge is often significantly larger and more robust. Think about playing an instrument. You need constant, rapid communication between the two hemispheres. The left side might be handling rhythm and reading the notes, while the right is processing melody, harmony, emotion.
So they're talking back and forth constantly.
Nonstop. And that intense communication literally builds up those connections, creating these neural superhighways for faster, more efficient processing. We also see changes in the motor cortex itself, like a violinist will have enlarged brain areas dedicated to controlling the fingers of their left hand. A pianist develops highly refined maps for coordinating both hands independently.
So it's not just learning a skill, it's physically changing the brain map.
Precisely. These are deep neural adaptations. They lead to more interconnected, more resilient, and more efficient brain networks overall.
That's incredible. And these changes, these adaptations, they build up something that helps us later in life. Is this where cognitive reserve comes in?
Exactly. All these structural and functional enhancements directly contribute to cognitive reserve. Think of it like building a bigger, better connected brain. It's the brain's capacity to maintain function despite age-related wear and tear or even disease. It gives you resilience.
So more connections, more pathways, like having detours available if there's a roadblock.
That's a perfect analogy. If one pathway gets damaged or slows down due to aging or something like Alzheimer's, a brain with high cognitive reserve has alternative routes to get the job done. Musical training is a fantastic way to build those extra routes.
Now, is it mostly kids who get these benefits? What if you start later in life? Is it too late?
That's a really important question. And the answer is a resounding no. It's absolutely not too late. While starting young does seem to provide the biggest, most lasting benefits, the adult brain keeps a remarkable amount of plasticity.
Really? Even for older adults?
Absolutely. There was one study looking at 13-year-olds starting piano lessons. They saw improvements in memory, attention, problem solving, even mood pretty quickly.
Okay, teenagers.
Makes sense. But then you have Dr. Jennifer Bugos's research. She studied older adults, average age around 70, I believe, who took piano lessons for 6 months. They showed significant improvements in processing speed, planning ability, and memory compared to a control group. 6 months.
Wow. So it really is never too late to pick up an instrument or start singing.
Never too late. The brain is ready to learn and adapt at any age. Music is this amazing, enjoyable way to give it that full workout we talked about.
Okay, that's super encouraging. Now, let's shift gears a bit to something I think resonates with almost everyone. Music's almost spooky ability to unlock memories. You hear a song from years ago, and bam! You're right back there, feeling the same thing, seeing the same scene. It's more than just remembering the tune, right? How does music do that?
It's an incredibly powerful phenomenon, isn't it? And you're right, it goes way beyond simple recall. It's about how music gets encoded in the first place. When we form memories, the brain links information together in networks. Music, because it's so layered, melody, rhythm, lyrics, maybe dancing, plus the strong emotions it evokes, creates incredibly rich multisensory memory networks.
Multisensory. meaning it connects to lots of different senses and feelings.
Exactly. Think about learning the alphabet song. You have the tune, the rhythm, the words, maybe even actions. If you forget a letter, the tune or rhythm can often pull it back for you. There are multiple pathways to the information.
Ah, like multiple keys to unlock the same memory.
Precisely. And then there's the research by Dr. Peter Janata on the reminiscence bump.
The what bump?
The reminiscence bump. It refers to the finding that we tend to have the most vivid, emotionally charged memories from our adolescence and early adulthood, say, our teens and 20s.
Oh, definitely. Music from high school.
Yeah. Well, Dr. Janata found that music from that period is particularly powerful in triggering these memories. When people listen to those songs, brain scans show activation not just in auditory areas, but critically in the medial prefrontal cortex.
And that part of the brain does.
It's a key hub for self-identity and autobiographical memory, the story of us. So hearing that music doesn't just bring back the song, it helps reconstruct the entire personal context, the feelings, the scenes, who you were at that time.
Wow. It's like a time machine for your own life story.
In a very real neurological sense, yes.
And this ties into why musical memory seems so resistant to conditions like Alzheimer's, doesn't it? How can someone forget their own name but still sing a song perfectly?
It's one of the most striking things we see. It comes down to the distributed nature of musical memory. Unlike some memories that are stored in fairly specific locations, like new facts relying heavily on the hippocampus, musical memories are spread out across many different brain regions.
So auditory areas, motor areas for rhythm or playing,
Yeah.
emotional centers.
Exactly. Language areas for lyrics, maybe visual areas if you associate it with a specific place or event. Because it's stored in so many places, if one area is damaged by dementia, other parts of the network can often still access the memory.
It's like having backups saved all over the place.
A very resilient backup system. That's why music can provide such powerful moments of connection and lucidity even late into the disease.
But music isn't just about old memories, right? Does it help us make new ones?
Oh, absolutely. It significantly enhances the formation of new memories. Information learned with music is generally remembered better and for longer.
Like those annoying advertising jingles you can't forget.
Exactly. Or educational songs for kids, or how cultures pass down history through song and chant. It works through something called elaborative encoding.
Elaborative encoding.
It means you're creating richer, more detailed memory traces by linking the new information to existing knowledge and, importantly, to sensory and emotional cues provided by the music rhythm, melody, feeling. More hooks mean easier retrieval later.
Got it. More ways in, more ways out.
Precisely. And there's more. Dr. Sylvain Moreno's work shows that musical training can actually boost your working memory capacity.
Working memory. That's like the brain's temporary sticky note, right? Where you
Yeah.
hold info while you're using it.
That's a good way to think of it. Holding phone numbers in your head, doing mental math, following complex instructions. Musical training seems to expand that capacity.
And does that help with non-music stuff too?
Yes, that's the key, finding it transfers. Better working memory from music practice helps with reading comprehension, problem solving, planning, lots of everyday cognitive tasks.
And you mentioned something even more radical. Music might actually help grow new brain cells.
That's the really exciting frontier. Emerging research, still early days, mind you, suggests that sustained musical engagement might promote neurogenesis, the actual birth of new neurons.
Where?
Particularly in the hippocampus, which is absolutely crucial for forming new memories and for learning. So music might not just be strengthening connections, it could be helping to build new brain hardware.
Literally growing your brain through music. That's amazing.
It's a tantalizing possibility that researchers are actively exploring.
Okay, from memory to potentially growing new cells, let's talk about the mental CEO, our executive functions, planning, organizing, problem solving, adapting, all that high-level stuff run by the prefrontal cortex. These skills are so important, but they often seem to be the first to get a bit shaky as we age. How does music step in here?
Music provides incredibly potent training for exactly those skills. Think about playing an instrument, especially something complex. It's basically extreme multitasking.
Rousseau.
You're reading notes, translating them into precise movements, listening to the sound you're making, controlling volume and timing, maybe coordinating with others, and thinking ahead to the next phrase, all simultaneously.
Right. That's a lot to juggle.
It's intense training for your executive function network. It forces your brain to manage multiple streams of information and action, constantly monitoring and adjusting.
Does this make musicians better at, say, switching tasks?
Yes, significantly. Research by Dr. Claude Allain, for example, shows musicians have enhanced cognitive flexibility. They're faster and more accurate on tests that require rapidly switching between different rules or tasks.
Faster than non-musicians.
Get this, in some studies, older adult musicians actually outperformed younger non-musicians on these kinds of tasks.
Whoa, outperformed younger people.
Yeah. It suggests music doesn't just slow down decline in cognitive flexibility. It might actually enhance it beyond typical youthful levels. It's what we call far transfer. The benefits spread beyond the musical activity itself.
That's incredible. What about focus? Resisting distractions.
That falls under inhibitory control, another key executive function. Musicians are constantly practicing this. Think about holding a steady tempo when you feel rushed, or focusing on your part when the rest of the orchestra is playing something complex, or ignoring a cough in the audience.
Right, you have to filter things out.
Constantly. This strengthens the neural networks responsible for focus, attention regulation, and inhibiting impulsive responses in all areas of life.
And problem solving. Does playing music help with that too?
Definitely. Music is deeply logical. It's full of patterns, structures, relationships, figuring out how a piece is put together, improvising within rules, interpreting a composer's intentions. It's all problem solving. It exercises the same kind of analytical and reasoning skills you use for everyday challenges, from planning a project to figuring out directions. It's like applied math and logic, but way more fun.
So all this strengthens that cognitive reserve we talked about earlier.
Precisely. It builds more robust and flexible executive function networks. Dr. Brenda Hanna-Platy did longitudinal studies showing musicians tend to have significantly slower rates of decline in executive functions and processing speed as they age. It's like building those backup systems specifically for your brain's CEO.
And again, is it ever too late to start building these executive function reserves through music?
Nope. The benefits appear accessible at any age. Dr. E. Glenn Schellenberg found older adults showed improvements in processing speed and executive function after just 4 months of music lessons. It really reinforces the message. Start now.
4 months. That's remarkable.
It is. And we should also mention the social aspect again. Playing in a group, a band, an orchestra, a choir adds another layer of executive function training.
How so?
You have to pay close attention to others, anticipate their actions, adjust your own playing or singing in real time, respond flexibly to cues. It's complex social cognition and adaptive behavior all wrapped up in making music together. These skills are vital for navigating social situations effectively throughout life.
Okay, so memory, executive function. Let's move to the heart, quite literally. Music's emotional power. It's universal. How does a sequence of sounds make us feel so much joy, sadness, peace, energy? What's the brain chemistry behind that?
It's fascinating, and it involves a whole cocktail of neurochemicals. When music hits you emotionally, your brain releases things like dopamine.
The pleasure chemical.
Exactly. It's involved in reward and motivation. Music can trigger dopamine release, making it feel good and making you want more. Research by Dr. Valerie Salampour even showed that dopamine spikes in anticipation of your favorite part of a song.
Wow, your brain knows what's coming and gets excited.
Precisely. It's predicting the reward. Music also boosts serotonin, which helps regulate mood and promotes well-being, and it can increase oxytocin.
The bonding hormone.
Yeah, especially when experiencing music with others. It fosters feelings of trust, connection, empathy, and importantly, music often decreases levels of cortisol, the stress hormone.
So it literally calms you down chemically.
It can, yes. This whole neurochemical symphony helps explain why music feels so good and can be so therapeutic. It strengthens the connections between our emotional centers, like the amygdala, and our thinking centers, like the prefrontal cortex.
Is this why music feels like an antidote to emotional aging, as some people say?
That's a good way to put it. As we age, those connections between emotion and cognition can sometimes weaken. Music helps maintain and even strengthen them, supporting better emotional regulation and resilience.
What about those intense moments, musical chills, goosebumps? What's happening then?
Ah, the chills. Brain scans show that's a moment of peak communication between emotional centers, reward pathways, and areas involved in attention and self-awareness. It's like your brain is firing on all cylinders, perfectly integrating emotion and cognition, a temporary state of optimal functioning.
And these effects are strong enough for actual therapy.
Absolutely. Music therapy is a recognized, evidence-based field. It's used for depression, anxiety, stress management, even pain relief and stroke recovery, leveraging these neurochemical and neural network effects. Even just listening passively has physiological effects. Dr. Stefan Kolsch's work shows music can regulate the autonomic nervous system.
Controlling heart rate, breathing.
Yes, slow, calming music can physically slow your heart rate and breathing through a process called entrainment. Your body literally syncs up. Upbeat music can energize you.
And the social side again, making music together.
Hugely important for emotion. Group music making boosts oxytocin and endorphins even more, strengthening social bonds, creating that feeling of collective effervescence, shared joy, and energy.
Collective effervescence, I like that.
And fascinatingly, when people make music together, their brain waves can actually synchronize.
Your brainwaves sync up.
Seriously. It helps people get on the same wavelength, literally fostering connection and empathy. This is incredibly valuable, especially for older adults who might be experiencing isolation. Overall, engaging with music builds emotional resilience, the ability to bounce back from stress, which is key to aging well.
That idea of syncing up, entrainment, seems like rhythm is fundamental to so much of this. Let's dive deeper into just rhythm itself. Our brains have their own rhythms, right? Brain waves, neural oscillations.
They absolutely do. These oscillations are like the timing signals that coordinate activity across different brain areas. And sometimes with age, the precision of this neural timing can decrease a bit.
So things get a little less coordinated internally.
Potentially, yes. And this is where musical rhythm comes in as a powerful tool. It can literally help retune these internal clocks.
Retune them how?
Think of a steady beat. Dr. Jessica Grand's research shows that processing rhythm engages key brain areas like the basal ganglia, cerebellum, and motor cortex regions, vital for movement, but also for attention and executive timing. Engaging with rhythm exercises these networks.
And that syncing phenomenon, entrainment, applies here too.
Big time. When you listen to a clear, steady beat, your brain waves tend to synchronize with that external rhythm. This actually improves the precision of your internal neural timing.
Even after the music stops.
Yes, the effects can linger. Studies show improved performance on attention and working memory tasks that rely on precise timing right after listening to rhythmic music. For older adults, this can be a real boost for cognitive sharpness.
Okay, so it sharpens internal timing. What about coordinating actual movement? You mentioned Parkinson's earlier.
Right. Motor timing is crucial. Tapping, clapping, dancing, these actions directly link auditory rhythm to motor output, strengthening those sensory-motor connections we need for walking, typing, everything. Dr. Michael Thout's work is groundbreaking here. Using rhythmic auditory stimulation, basically, walking to a specific beat helps stroke patients relearn to walk more smoothly.
How does it help Parkinson's patients?
It can significantly improve their gait, reduce those moments where they freeze, and enhance balance. The idea is that the external rhythm provides a clear timing cue that can bypass damaged pathways in the basal ganglia, offering an alternative route for the brain to control movement timing.
Like an external pacemaker for movement.
In a way, yes. A temporal scaffold. It's also used for traumatic brain injury recovery.
Does rhythm help with language too? Speech has rhythm.
Absolutely. Speech relies heavily on precise timing, syllable duration, pauses, intonation patterns. Musical rhythm training enhances these linguistic timing skills, which can improve both speech production and comprehension. It might be one reason musicians often excel at language.
And the social synchronization again? Group drumming, maybe?
Yes, group rhythm activities are fantastic. Drum circles, for instance, combine that intense rhythmic entrainment with physical activity and powerful social bonding through shared brainwave synchronization. It fosters cooperation and empathy.
Plus, rhythm can be meditative, right?
Definitely.
Yeah.
Repetitive rhythmic activities can induce relaxed, focused states similar to meditation, promoting stress reduction and boosting alpha brainwaves, which are linked to creativity and well-being. Rhythm is fundamental.
It really seems to underpin so much. Okay, so we've established active playing is incredibly powerful, but let's circle back to listening. For someone who maybe isn't going to pick up an instrument, how significant are the benefits of just listening? Is it really passive?
That's the key question for many people, and the answer is listening is far from passive. Your brain is incredibly busy even when you're just listening.
Doing what?
Well, for one thing, it's constantly engaged in predictive processing. It's using its knowledge of musical patterns to predict what note or chord or beat comes next.
And when it guesses right?
You get a little hit of dopamine, a feeling of satisfaction. When the music does something unexpected but still makes sense, it grabs your attention, engages your analytical circuits. It's constant prediction and updating, great training for the brain.
Even if I'm not consciously trying to predict.
Yes. And Dr. Stefan Kolch found the brain processes musical structure and emotion even with background music you're not actively focused on. So even ambient music likely provides some low-level cognitive stimulation.
Does the type of music matter? Is complex music better?
Generally, more complex music, like classical or jazz, demands more processing power, so it probably offers a greater cognitive workout in terms of pattern analysis. However, familiarity allows for deeper emotional connection and maybe more detailed prediction.
Or a mix is probably good.
Likely ideal. Familiar music you love for the emotional and reward benefits, and some more complex or unfamiliar stuff to challenge your brain's processing systems.
And what if I really focus while listening, like active listening?
That definitely amplifies the benefits. Consciously trying to follow the bass line or identify different instruments or track the harmonic changes that intensely engages your sustained attention, working memory, and analytical skills.
Makes sense.
Plus, the pure emotional engagement is crucial. Letting music move you strengthens those vital connections between your emotional brain and your cognitive brain and helps consolidate memories linked to that emotion. And don't forget group listening concerts, singing along that taps into social cognition and bonding. Music inherently trains temporal integration too, processing sequences over time.
And you mentioned a specific study earlier, the Mazziarini's one, about brain age. Can we just clarify that again? Because it sounded like it found something different from other studies.
Yes, it's important to be precise here. Brain age is a specific metric derived from MRI scans, trying to estimate brain age based on structural patterns compared to a large database. This particular 2023 study did not find a direct correlation between simply being a musician and having a younger-looking brain according to that specific brain age metric. That differs from some earlier findings using different methods or metrics, like the Rogen-Moser study from 2018, which did find younger brain indicators in musicians.
Okay, so one study, one specific measure, showed no direct link for musician status. But did it say music wasn't beneficial?
No, absolutely not. This is the critical point. The same Mazziarina study did find that musical training and active musical engagement were strongly related to what they called the resilience factor of challenge.
Resilience factor?
Yeah. They suggested that musical activity strengthens the brain's resilience to age-related changes, which taps into that concept of neurocognitive reserve. So while that single brain score might not have captured it directly in their analysis, the study still supports the idea that music builds a more resilient, adaptable brain.
So it's not necessarily making the brain look younger on that one specific scan, but making it function better and withstand challenges more effectively.
Exactly. It highlights that brain health is complex, and maybe resilience and flexibility are better indicators of music's benefits than just one structural age estimate. The study also noted physical activity did correlate with brain age, reinforcing that multiple lifestyle factors matter. The overwhelming consensus from the broader field remains. Music profoundly benefits brain health and function, especially in terms of building that crucial reserve and resilience.
That's a really helpful clarification. It's about the bigger picture of resilience. Okay, building on that, let's talk practical applications in healthcare. Music therapy, it's becoming much more mainstream, right? Especially for aging brains.
Absolutely. It's moving from the fringes to being a recognized, evidence-based component of care. We see it used very effectively in dementia care. As we discussed, those musical memories often stay remarkably preserved. Dr. Oliver Sacks wrote beautifully about this. Personalized playlists, songs from someone's youth.
Like the Music and Memory program.
Exactly. These can trigger periods of lucidity, reduce agitation, improve mood, and allow for connection even when verbal communication is difficult. It works by activating those preserved networks and releasing those feel-good neurochemicals.
It offers a way in when other doors seem closed.
Beautifully put. And for Parkinson's, as we touched on with rhythm, rhythmic auditory stimulation is a powerful tool to improve gait, reduce freezing, and enhance balance by providing that external timing cue.
Bypassing the damaged parts.
Essentially, yes, offering an alternative pathway for motor control. In speech therapy after stroke, melodic intonation therapy uses singing.
Because singing uses different brain pathways than speaking.
Primarily, yes, often engaging the undamaged right hemisphere more. Patients who can't speak might be able to sing words, and therapists use that as a bridge to rebuild conversational speech.
Fascinating. What about mood disorders?
Music therapy, especially group music making, is very effective for depression and anxiety in older adults. It provides social connection, emotional expression, a sense of accomplishment, plus the direct mood boost from dopamine and serotonin release.
And pain. Can music really help with physical pain?
Studies show it can. Listening to preferred music can reduce pain perception, lower anxiety about pain, and sometimes even reduce the need for pain medication. It likely works through distraction, emotional modulation, and releasing natural endorphins.
Even sleep.
Yes, slow, calming music before bed can improve sleep quality by promoting relaxation, reducing cortisol, and helping to regulate the body's internal rhythms.
And technology is playing a role now, too.
Definitely. We're seeing digital platforms for personalized music interventions, even virtual reality being used for music therapy applications like managing chronic pain or PTSD. But the human element, the trained music therapist, remains absolutely key for tailoring the approach and building that therapeutic relationship.
It's incredible how versatile it is as a therapeutic tool.
Okay.
Okay, let's bring this home for you, the listener. We know it's powerful. We know it's beneficial at any age. How do we actually do it? What are some practical ways to build our own musical brains?
Right, the actionable stuff. The great news is you don't need to aim for Carnegie Hall. Regular, active engagement is the foundation.
And active doesn't just mean playing an instrument.
Not at all. Singing along in the car counts. Tapping out rhythms on your desk counts. Mindfully moving or dancing to music counts. Anything where you're consciously interacting with the sound and rhythm.
Okay, so start there. But if someone is thinking about learning an instrument as an adult, any recommendations?
Go for it. Piano is great for the reasons we discussed: bimanual coordination, clear visual feedback. Guitar is super popular, portable, social. Ukulele is often seen as easier to start, but honestly, the best instrument is the one you're excited about and will actually stick with.
Because consistency is key.
Absolutely. And remember, as an adult learner, you bring strengths, focus, analytical skills, motivation. Don't be intimidated.
What about practice? Just noodling around? Or does it need structure?
Some structure helps maximize benefits. Aim for deliberate practice. That means focusing on specific, challenging things, even if it's just for a short time. Work slowly on tricky bits. Push your comfort zone slightly. That's what really drives neuroplasticity.
And group activities?
Yeah.
Choirs, bands.
Highly recommended. Joining a group, musical activity, community choir, orchestra, drum circle, even a casual jam session is fantastic. You get the cognitive challenge, plus huge social and emotional benefits. That oxytocin boost, the shared goal, the support network. It's powerful.
What about using apps or online resources?
Definitely leverage technology tools. There are
Yes.
amazing apps for learning instruments, understanding music theory, even composing. Online tutorials abound, makes it very accessible.
And for listening, how can we optimize that?
Be an active listener sometimes. Don't just have music on, really listen. Follow one instrument, notice the harmonies, pay attention to the structure, and diversify your genres.
Get out of the comfort zone.
Yes. Explore jazz, classical, world music, something complex or unfamiliar. Challenge your brain to build new processed pathways. It doesn't mean you have to like everything, but exposure is stimulating.
Any other tips for integrating music more?
Sure. Combine music with other things: upbeat tunes for exercise, calming music for relaxing, play musical games, create musical memories, intentionally learn songs that mean something to you, make playlists for special occasions, share music with loved ones.
And remember, consistency.
Consistency over intensity. Even 15 minutes of focused engagement daily is likely better than one long session once a week. Create a good environment if you can, dedicated space, good light. Start simple and gradually progress. Maybe keep a journal. Track your progress, notice changes, and most importantly,
Let me guess, enjoy it.
exactly, focus on the joy, the process, not perfection. It's a lifelong journey, not a race.
Fantastic advice. What an incredible exploration this has been. It's so clear that music is way more than just background noise or entertainment. It's this potent, accessible tool for keeping our brains healthy, sharp, and resilient throughout our lives. And the message that it's never too late is just so hopeful and empowering. Whether you pick up that dusty guitar, join a choir, or simply commit to listening more deeply and exploring new sounds, you're actively nurturing your brain. So I really encourage you, our listener, take that first step, whatever feels right for you. Because unlike a lot of things we do for our health, engaging with music rarely feels like a chore. It feels like joy, like connection, like celebration.
It really does. And maybe a final thought to leave you with. Your brain is already this incredible symphony of neurons, constantly playing, adapting, learning. The real question isn't whether you have musical potential. Every brain does. The question is, will you choose to consciously conduct that amazing orchestra? Will you guide it towards greater harmony, deeper resilience, and more profound joy? How will you choose to add your own unique notes to the grand composition of your cognitive health, starting today?
A beautiful and powerful challenge. Thank you for guiding us through this fascinating deep dive. And thank you for listening. Keep exploring, keep engaging, and keep nurturing that amazing musical brain of yours.